resistors, each of resistance 1 ohm is connected as shown. The current passing through the AND resistor is 1 ampere. So what is the potential difference across the input terminals? So they're asking us to figure out what this voltage is if you, for example, connect a voltmeter. And as they're not telling us anything about internal resistance, we're not going to be considering IR. So for this specific question, the current through this resistor, is actually 1 ampere. So if the current through this resistor is 1 ampere, that means that the current through this part of the circuit is also 1 ampere. That means the current through this resistor is also 1 ampere. So now this question is really good because it really tests your understanding of circuits and the general way that circuits work. So that's essentially what I'm going to be doing today in this video, is that I'm trying to develop the understanding of circuits. So the current through this resistor is 1 ampere. That means the current through this resistor is also 1 ampere. Right? And that means that essentially current, let's consider this to be the positive terminal and this to be the negative. So when current was, let's say, flowing through here, it was going through here and it just went here. It went through this, and then once it came into a junction, it was at a crossroads. It could be going here or it could be going here, and that's why the current split into 2 pots. Similarly, when the current that decided to flow through here comes across here, in this junction it needs to split again and then go here and here. So the way that we're going to be working with this is essentially that we know that the current here is 1 ampere. So essentially, if this is 1 ampere, if the current here has 2 options, either to go this way, which is just 1 ohm, and then probably get back here. This is just 1 ohm in its path, or it could be going through this resistor here and this resistor here. I'm putting an and. So essentially, when you've got like 2 resistors, you're having 1 amperes. So if you've got 1 resistor, you will have 2 amperes flowing. So that is actually the sort of logic. Okay, so why is this the case? That's because this current here needs to be split into this. So like into here, it could either choose to go here or it could either choose to go here. All right, and we clearly can see that the resistance in both pots are different. So here we have got 2 resistors, and here we have got a single resistor. So if the current through 2 resistors is 1 ampere, then the current through 1 resistor would definitely be double, because we know that the current is inversely related to the resistance, right? And similarly, therefore, we can say that if this part is 2 amperes and this part is 1 ampere, that means the current through here is definitely 3 amperes. And therefore, we know that the current through this 1 ohm resistor is 3 amperes. We're going to be applying a very similar logic to the rest of the circuit as well. So again, as we arrive at this junction, the current has again 2 options. It could go here where there's like a single resistor, or it could choose to go here. Now, the only difference is that in this pot, this is not just a single resistor that it needs to go through. It needs to go through this. This pot also contains all of these segments, right? It contains all of these segments as well, and therefore it's pretty important to consider these segments as well in our calculations. So previously it was quite easy. It was like 2 resistors, 1 ampere, so from 1 resistor 2 amperes. Well, now the calculations are a bit complex for this part. So essentially we can say that we know from facts that essentially the current that's passing through this part of the circuit is actually 3 amperes. And what we're trying to find out is actually the current through this part of the circuit, right? So we can use the simple relation I1 over I2 is equal to R2 over R1. Now, So essentially what is our I1 and what is our I2? So the current that's passing through this part of the circuit is our I1. So that's 3 amperes, and I2 is the current that's passing through this resistor here. So that's what we're trying to find, right? And so the resistance 2 is simply 1 ohm, is simply this 1 ohm, divided by the resistance 1. Now, the resistance 1 is essentially going to be this entirety of the circuit, okay? This is going to be this entirety of the circuit. Well, how are we going to be calculating that? It's quite simple, honestly. So we'll be doing it very simply. So I'll just look at our resistors here. This is 1 ohm and this is 1 ohm. These are connected in series. So 1 ohm plus 1 ohm and this 1 ohm and this 1 ohm are connected in parallel to this 1 ohm. So that makes it 1 over 1 plus 1 over 1 plus 1, that's 2 ohms. And this gives us actually a value of, well, let me just calculate in my calculator. That's 1 over half plus 1, and the inverse of that gives us 2 by 3 ohms, right? 2 by 3 ohms. So essentially, these two are in series, and these two are series are parallel with this. That makes it 2 by 3. Now this and this are actually, basically you just calculated what? You just calculated this part, right? This part and this part in series with this part, so 2 by 3 plus 1 is actually equal to 5 over 3, right? That's equal to 5 over 3 ohms. So this part of the circuit is actually 5 over 3 ohms. Now we can just plug that in our calculations, and that tells us that the current I2 is actually equal to 5 amperes. Now I think I should erase this because this makes the diagram quite a bit messy. So we just calculated that our current through this part of the circuit is actually 5 amperes. And we already know through here it is 3 amperes. That's the main logic. We said that, okay, I do know that the current through here, sorry, that's 3. So the current through here, this part of the circuit is 3 amperes. And I know the resistance to this part of the circuit is 5 over 3. And I need to figure out the current to this part of this resistor, and this is the current, so 5 and 3. So again, there was this junction, the current decided to split 3 amperes here and 5 amperes here, definitely because there's more resistance there. So total it was 8 amperes right here. That means 8 amperes was flowing through this resistor, and therefore 8 amperes is actually the total current in the circuit, right? Now, we are asked to figure out the potential difference V. Now, we know that V total is equal to I total times R total. Well, we just figured out our I total, and we're asked to figure out this. So what is our resistance total? We already know that the total resistance here is, like, basically the total resistance in this part of the circuit is actually 5 over 3 ohms. Now, this part of the circuit is actually, well, that looks like it's in parallel with this 1 ohm, right? So essentially, if we do our math correctly, if these are in parallel, they should give us a resistance of 1 divided by 5 over 3 plus 1 over 1 and the inverse of that. Well, that gives us 5 over 8. Alright? That gives us 5 over 8 as the total for this part, right? Now what is interesting is that this part of the circuit is 5 over 8 ohms. Now this part of the circuit is in series with this resistor. So we just add 1 to that, 1 ohm. So we get 1.625 ohms. So that is the total resistance, right? That's the total resistance. So the current total, so we just figured out over here, that's 8 amperes times the total resistance, which is 1.625, which gives us a value of, well, 13 volts. So our correct answer is D.